All right, so hopefully you're ready. Are you ready? Ready? You ready? Why don't you have your calculator out? Ask for a calculator. All right, class. Thank you. All right, so we're going through the reteaching of Unit 1, Limits and Continuity of Trigonometric, Exponential, and Logarithmic Functions. So we've already done this, but I want to go because it needs more continuity. I need to turn my screen. Needs more cowbell. Okay, everything needs more cowbell. All right, so let's see. Bam. Squeeze theorem. We've already talked about squeeze theorem before. If I know that my function is going to be between two different ones right here, then I know as I get closer and closer to that, I can squeeze it in between those two functions to be able to get an actual answer there. So I want the left side, the f, equal the right side, the h. And so if I have the left side and the right side together, they are going closer and closer and closer to be the g. That's what I'm trying to do. I'm trying to squeeze that in there for the problem. All right. Basic trigonometry right here. So the limit as sine goes to 0, my answer is going to be 0. That's going to be right here on my graph. So limit, that one's going to be basic right here. Another one, limit as cosine goes to 0, it's going to be up here at 1. That one will just plug in right there. So sine and cosine do not have any restrictions on their domain. It is a wave. It goes all the way to the left and goes all the way to the right. So the domain for that is going to be from negative infinity to positive infinity, like this. Now, here's another thing that we should talk about. Is infinity ever bracketed?
Never.
Never. Why never?
Because there's no solid.
It's not a number. It's not somewhere on the number line. So it cannot be equal. It's an idea. It's not a number. So it can approach infinity, but cannot be equal to infinity. Finding the limit, trigonometric function right here. So, can I plug in 0 for this one?
No.
No. But I know that sine of theta, so limit as x, oh, this one's theta, sorry, approaches 0 is going to give me 0. So that one is going to be 0. So even if this right here says it's going to be 3 times 0, 3 theta, so if I'm plugging in 0 there, 3 times 0 is still 0. Sine in 0 is still 0. But now, over the bottom is approaching 0. So if it is approaching 0, couldn't that be like 0.00001 or something like that? Now, let's try it in the calculator and see what you get. So from here, we know that it's going to be undefined right here on the bottom. But on top is going to be 0. So if I take a guess at it, what would you think it would end up being? It's approaching 0, but it's not going to be equal to 0. So if it's approaching 0, think about it. On the bottom, it's going to be a very, very, very small number. But sine of 0 is also going to be a very, very, very small number. it's going to get close to 0, isn't it?
Yeah.
So let's take a look, and hopefully this one will work today, because it wasn't working the other day. Ah, it's loading. Good. There we go. All right, so I'm going to go here. What mode should my calculator be in?
Radian.
Radian, very good. So control, divide, I have sine of 3x. I don't need to put the thetas there because it means the same thing, over x. And let's see what we get. All right, so now as it's approaching 0, uh-oh, what's happening right there?
It peaked up.
So it looks like it's going to be 3. It's going to be 3. So now if we're looking at this, so what do you think that the sine of x over x is going to give me?
Sine over x.
Sine of x over x. If this gives me 3, what do you think sine of x over x is going to be?
1.
Let's try it.
Yeah.
Hey, look. So using this information right here, whenever I see sine of x over x, I know that's going to be what?
1.
1. So I could use this information here now, and I could probably make a rule out of this. Here's the cosine one. But we know that the limit as x or theta approaches 0 of sine of x or theta. Damn it. You didn't hear that on YouTube. Over theta is going to give me 1. And so now going back to that, I now have a formula I can try and use. So if sine of x over x is going to give me 1, let's see, so sine of 5 theta to theta. Now, before you actually enter this one in the calculator, take a guess at it.
Want me to say it?
Go ahead, say it.
5 over 2.
5 over 2. So if that was a decimal, I would say that's going to be 2.5, right? Okay, let's see what the calculator says. And then I'm hoping you guys could actually see patterns for each one of these. Hit tab again, and I'm going with control divide sine 5x over sine 2x. Wow, that one's crazy, isn't it?
Oh.
It's crazy. That's cray. But let's trace it now. So it says it's still undefined at 0, but what does this number look like it's going to be?
Is it above 1, around 0? Wait. 2.
There it is. Right here. I'm on the black one. So it is right above there. So now that I have trace on in your calculator, all you can do, you could put in a number really close to it. So I want 0.001. So it is going to be my 2.5. So very good. So what happened there with my signs?
But he hasn't done anything over here. Barely just the run, which for my class today, is it take a run for that list to show up?
Just hit that refresh. Everything should be there automatically.
I don't know why this is.
So sine of theta over theta, what do you think sine of theta over theta is going to give me?
1.
I'm sorry, sine of theta over sine of theta.
1.
1. So by using this and checking out the calculator, I could actually look at this and see some of these limits now and make rules out of it, because every time I see it now I can know, oh, I could just use that. Here's another rule that we have. Cosine theta minus 1 over theta. If I take that limit, it's going to give me 0. So that is another one that you should be able to look at and be like, oh, hey, you know, little magic thing comes up in your brain, the little light bulb comes on, and you guys, oh, that means something over here. So I could use that to be able to solve a lot of these. All right, so sine is continuous at 0. It's always continuous. It's like I said, that it is domain all real numbers from negative infinity to positive infinity. Cosine has that same thing. Here is all the, yes. So the inverses and all the reciprocals. So tangent has a asymptote where it's not equal at multiples, at odd multiples of pi over 2. So 1 pi over 2 doesn't work. 3 pi over 2 doesn't work. Does that make sense?
Yeah.
5 pi over 2 doesn't work.
So 4 pi over 2.
4 pi over 2. What is 4 pi over 2? What is 4 over 2?
It's 2, so 2 pi.
2 pi. 2 pi, it does work. It gives me a 0. Okay, tangent at 2 pi is 0. So cosecants at every multiple of pi, it is undefined. At secant, odd multiples of pi over 2 is going to be undefined. And cotangent at multiples of pi. So inverses also, but these waves, instead of going left and right for my wave, it would now, the inverse goes up and down. So the wave would be traveling up and down on this. All right, and the continuousness of that. Now, continuity of exponential and logarithmic functions. Now, a lot of problems that people have is with logs and where it exists. So, exponential function continuous on its domain, all real numbers. Logarithmic functions continue on its domain, all positive real numbers. Positive real numbers. Logs do not exist from 0 into negative numbers. 0 to negative numbers. So it has to be greater than 0. And A cannot, so A is a base. and it cannot be equal to 1. So, for this right here, I can't plug in for what's the log base 2 of some number and like try to plug in a negative in there. It's not going to work. It doesn't exist there. Here is some more rules that go along with this. So, the limit of a, so it's just some constant, it doesn't have an x value, is just going to be a. It doesn't have anything to plug in. Say, okay, let's say we have the function f of x equals 2. The limit for that, no matter where it's at, is going to be 2 because there's no variable to plug it into. So if it's just 2, that's what that means for a constant. If this is just going to be x, there's only an x right there, so that means I plug in the c for the x. My answer is going to be whatever this number is, the c number is. Okay, limit for these ones right here. Here's that rule again for this one. Here's another one for the cosine. Limit for exponentials right here, where a has to be greater than 0. Can't be right there, and it cannot be equal to 1. Limit for the logs right here, where c is greater than 0, and a is also greater than 0, but not equal to 1. It could be a decimal. So in between 0 and 1, it could be a decimal there. Just can't be equal to 1. Alright, so those are the rules that actually go along with the rest of this stuff right here. And that's the reason why I wanted to go over this. And I want you to try out the problems now. So we have today, so 1.4, the homework set for 1.4 is going to be right...
It's still in the old textbook, right?
Yep, we're going to be using the old textbook until further, yeah. All right, so make sure you guys all like, share, and subscribe. Hit that notification button, support my channel. Buy stuff from my merch store.